Are we? All right, notebook 4. All right, so this notebook is on loops, and we're going to cover in it the syntax for while and for loops in Julia. Now first off, to write a while loop in Julia, we use the while and the end keywords. And typically what we'll do is we'll put the condition that we are going to evaluate for veracity on the same line as our while keyword, and then we'll have, often for readability, an indented loop body between the lines that contain the while and the end keywords. So an example of what a while loop might look like in Julia is the while loop that I've included here, which counts from 1 to 10 and prints the numbers 1 to 10. And another thing that I'll note here is that this indentation, while nice for readability, is not necessary. So this loop will run exactly the same way if I simply indent the second line but not at all the first line. And I can add arbitrary numbers of spaces, because Julia for the most part is not white space sensitive. When I say for the most part, what I mean is that Julia can tell that there's a return statement here to delineate two different lines of execution, but Julia doesn't care about indentations or spaces. The second example of a while loop is here, where I'm iterating over an array to greet all of the inputs of that array. And now we'll do exactly those two same actions using for loops in Julia. So the syntax for a for loop in Julia is to use a for keyword, an end keyword to terminate the end of our for loop. And on the same line as this for keyword, we're going to put first a local variable that will take on the values of the elements in the collection or the range that here I'm calling my loop iterable, or the thing that my loop is iterating over. And we have this keyword in here to separate the variable that's going to take on different values and the loop iterable. And so here's an example of a for loop where we count from 1 to 10. And so we're assigning different values between the range 1 and 10 to this local variable n, and then printing the results. So this is the first time that we've seen a range in Julia. To create a range, we're specifying the beginning of our range, putting a colon, and then the end of our range. Another way that we might create a range is to specify how we want to step through a range, starting with our first number and ending with our last number. And we can do that by adding the step size as a third number between the beginning and the end, and then adding another colon to separate it from our other two numbers. So here I'm saying I want to take steps of 2, so I'm only printing the odd numbers when we run this loop. And similarly, as above, if we wanted to greet all the elements inside this array my friends, we could use a for loop to do that, where now the loop iterable that I'm using instead of a range is an array. And it could be any other type of collection as well. Okay, so in these next examples with for loops, we're going to create some addition tables. And really, so you know why we're doing this, the motivation is to show you different ways to embed for loops within other for loops. And also, we're going to slip in the notion of array comprehensions. But the way that we'll be doing this is by creating, as I said, addition tables, where addition tables are going to be matrices that for every element of the matrix, the elements will be equal to the sum of the row and the column index. And the first way that we'll do this is by initializing a matrix A to be filled with zeros, and we'll populate it thereafter with the values we actually want. Now we've generated this matrix of zeros here using the fill command. The fill command takes as a first input argument the value that I want to use to populate all the elements of the array I'm creating. And as the second input argument, I can pass a tuple specifying the dimensions of the array I want to create. So here I'm saying I want a 5 by 5 array that's filled with all zeros. Now that I've created that matrix A, we here are creating a nested for loop, one for loop inside the other, that goes over all the rows and all the columns of the matrix A and updates the elements to what we want them to be. Now, here's our first bit of syntactic sugar with generating nested for loops. That we can again start by creating a matrix of zeros, and now we can populate this new matrix of zeros B exactly the same way we did above, but with slightly different syntax. And we're doing that by removing our second for keyword and our second end keyword, and we are putting what was formerly our embedded for loop here, where we iterated over j from values 1 to n. we're putting that on the same line as the line where we tell I to go from 1 to m. And we've separated our specifications for what I should do and what j should do by a comma right here. And we can do this for arbitrary loop depth. We could, continue adding, k in 1 to, 10 if we wanted to, 1 to 10. But we won't. For now, we'll just create the same sort of addition table. And so that can give you an edge. It's really nice if you have many loops to just be able to sort of specify everything at once. It can make your code a lot cleaner. And now the third way that we might have done this is with an array comprehension, but we haven't talked about array comprehensions yet. So I want to show you what that looks like first. Let's start by talking about a 1D array comprehension. So when I say array comprehension, what I mean is that I'm going to generate an array that sort of auto-fills itself. So I'm going to put code inside of an array to tell the array how it should be populated. So if I wanted an array from 1 to 10, I might just type the values that I want. I could say I want an array that has 1, 2, 3, 4, 5, etc. Alternatively, I could say, here are my square brackets. Inside my square brackets, I'll say for x in the range 1 to 10, include an x. And I'll say that by putting an x to the left of my for keyword. When I run this, I am going to get this array from 1 to 10. I can do more complicated or complex things here. I could say, for example, 2 times x for x in 1 to 10, and now we've doubled all the elements of the array there. So this is the syntax for an array comprehension, and we can do this with multiple dimensions. So we could create an addition table, for example, with the code that I'm showing here, where again, we have this syntax that we stole from above. If you were to scroll up, it would be exactly the same for that syntactic sugar embedded for loop. The first line of that for loop is this for statement that I have highlighted here. And then to the left of that, we're putting what was essentially the loop body of the previous for loops that we've written. And so here we've on the fly generated our addition table, and one of the things that's cool about that is this was the first time we created an addition table where we didn't have to pre-initialize that matrix of zeros. Okay, so that is it for loops.